Today we'll be solving Leetcode product of array except self. How you guys doing, by the way? Yeah, so let's just read the question. Given an integer array norms, return an array answer such that answer index is equal to the product of all the elements except from the norms I. The product of any prefix or suffix of norms is guaranteed to be 32-bit integer. You must write an algorithm that runs in O of n time without using division operators. So, for example, 1, 2, 3, 4. You get a result of 24, 12, 8, 6. Alright, and then this, you get a result of this. So, what this question is asking for is for you to, when you are given an array, return another array whereby the index is the multiplication of the rest of the elements. So for the first index, the multiplication of the rest of the element. So for index 0 is multiplication of index 1, 2, and 3, which is 2 times 3 times 4, which is 6 times 4, which is 24. For index 2 is the multiplication of 1, 3, and 4, which is 12. Index 3 is multiplication of 1, 2, and 4, which is 8. Index 4 is multiplication of 1, 2, and 3, which is 6. So basically, like this, something like this. 1, okay, my pencil. 1, 2, 3, and 4. Yes, so you get a result of multiplication of this 3 will give 2 times 3 times 4 is 24. The multiplication of at this index is going to be multiplication of 1 and this, which is 12, and the next index is multiplication of these 2 and this, which is 8, and the next is the multiplication of the rest of 3, which is 6. Yeah, okay, so this question is easy to solve if you can use the division operator, right? All we just need to do is at each index just multiply the rest of the elements, or better still, we can first calculate, we can first multiply everything. 2 times 3 times 4 is what? 6 times 4, 24. Then at every index we divide by the current index. So 24 divided by 1 is 24, and 24 divided by 2 is 12, 24 divided by 3 is 8, and 24 divided by 4 is 6. That works. But which is a of n solution. But the told us not to use the division operator. Although the division operator will not have worked with this because of anything divided by 0 would have given me infinity. So as when we had something like this, we have gone for the test cases in which we have a 0. In that situation, anytime we have a 0, we know that we're not going to divide by 0, we just multiply by the rest. And if we have multiple 0, we know that the whole thing will be 0, right? So if you have an example of 1, 0, 0, 5, 6, the result will be 0, 0, 0, 0, and 0. Because of at index 1 is going to be 0 times the rest, 0. At index 0 is going to be 1 times 0 times 5 times 6, 0. At index 0 is going to be 1 times 0 times 5 times 6, 0. Index 5, 1, 0, 0, 6, 0. Index 6, 0. Yeah, so how do we solve it without using the division operator? Alright, so let's go into the trick of solving it. It's actually quite interesting, as we say now. So we have 1, 2, 3, 4. So if we want to multiply get the multiplication, the matrix of the multiplication excluding it, we could figure out a way of multiplying everything behind and then multiplying everything in front. For example, at index 1, we're going to do something. We're going to multiply everything behind index 1. Then moving forward, we'll multiply everything behind. So at index 1, we'll have 1 times nothing. So we just put 1. At index 2, we'll multiply everything behind. So it's just going to be 1. At this index, we'll multiply everything behind. So it's just going to be what? 2. And at this index, we'll multiply everything behind. So it's going to be what? 6. Now, you know that we've multiplied everything behind. We now go again and this time multiply everything in front for each index. So at index 4, or we can also go at index 1 and just multiply everything in front. But at index 4, we multiply everything in front, which is nothing basically. So it's just Oh, okay. Which is nothing basically, so it's just 6. At index 3, we multiply everything in front, which is 4. Then we multiply the current element, which is 4 times 2, 8. At this index, we multiply everything in front, which is 12, times the current position, which is 12. And then at index 1, we multiply everything in front, which is 24, times the current position, which is 24. I'm going to explain again to make it. So basically, this is what I'm doing. When I have 1, 2, 3, 4, the multiplication of everything of the array excluding that index is basically the multiplication of the left part, everything to the left, multiplied by the multiplication of everything to the right. So at index 2 is going to multiply everything to the left and everything is right. At this index is going to be multiplication of everything to the left and everything to the right. So what we're doing is we're going to loop throughout 2 times. The first time we're going to make sure create an array that multiplies everything to the left, and the second time we're now going to update the array with the multiplication of everything to the right. Let's use a new example. Okay, let's kind of manage our space. So 4, 2, 5, 6. Hey, we'll be able to multiply this like this. Yeah, so we know that our result should be, let's calculate our result manually. So we expecting our result to be something of 2 times 5, 10 times 6, 60. At index 2, 2 times 5, 20 times 6 is what, 120. At index 5, 4 times 2 is 8, 8 times 6 is 48, if I'm correct. And at index 6, 4 times 2 is 8, 8 times 5 is what, 40. So this is what we should be expecting. But using our algorithm, we're going to first of all create an array. So we would first multiply everything to the left. So at this index, we'll multiply everything to the left, which is just 1. So everything to the left of 4 is nothing, which is just 1. At index 2, we multiply everything to the left of 2, which is just 4 times 1, which is just 4. At index 5, we multiply everything to the left, which is 4 times 2, 8. At index 6, we multiply everything to the left, which is 4 times 2 times 5 is what? 8 times 5 is what? 40. This first array is everything to the left. Then we continue. The next array will be everything to the right. We can decide to start from here, or we can start from here. But I'm going to start from here, and I'm going to explain the reason why I'm going to start from here very soon. So back to my new updated array. So I'm going to take at this index everything to the right of this. Then I'm going to update it to my previous answer that has calculated everything to the left of this. Remember, everything to the left of this has been recorded in this array. So everything to the right of this is 1. 1 times what is to the left of it, which is 40, is 40. At this index is going to be everything to the right of it times everything to the left of it. Remember, in the first array, we've calculated everything to the left of it. So what we're just going to do is calculate everything to the right of it, multiply by what we've calculated as everything to the left of it. So it's 6 times 4, 48. At this index, everything to the right of it is 5 times 6, 30. 30 times everything to the left of it, which we've recorded yet. 30 times 4 is 120. And finally, at this index is everything to the right of it times everything to the left of it. Everything to the right of it is what? 6 times 5, 30 times 2, 60. Multiplied by everything to the right of it has been recorded here. That's what? 60. And that is our final answer. Alright, so how do we transfer this into code? Well, it's quite simple. We're going to have first of all, we're going to have an array where we'll be storing our, let's just call it U, because we'll be updating it, right? Then the first thing is in our first for loop, we'll be updating it with the values. Now the reason why I'm starting from the left and right is I want to keep memory. I don't want to, if at this index I don't want to start multiplying this times this. At this index I don't want to start multiplying this times this. So we know that when you get to, if we start from index, let's say we start from index 2 and we have everything to the left as 4. At index 5 is simply, as index 5, everything to the left is simply everything to the left are 2 times 2. which is 8. We don't need to start going 2 times 4. We already know that everything to the left is 4 before, then we multiply by 2. At this index, it's simply everything to the left of 5, then multiply by 5. If you're with me, everything to the left of 5 is already 8, which we've calculated in the previous execution. So 8 times 5 is what? 14. Yeah, so we're going to have something, we'll call it pre. Let's just call it pre-sum. So we'll start at 1, right? So the first loop would loop updating the array and updating the pre-sum. At first we'll put 1, right? Then the next pre-sum is, so if we have, let's just use this. The next pre-sum would be 1. Then at 2 it's going to be everything to the left, which is 4 times, which is 1 times 4. So pre-sum would have updated to 4. Yes, and then pre-sum would be updated to everything to the left, which is now 8. Then pre-sum will be updated to everything to the left, which is now 40. Right. That's the first array. Then the next array, we'll call it post-sum. We'll also start from 1, but this time we'll be starting from this side. So updating these two. Everything to the left of it will be 40 times 1. Then we'll update post. Post now becomes 1, basically. Post becomes 6, sorry. So post becomes 6. Then we update, then we multiply again. Everything to the left of it will be, at this point, will be 8 times 6, which is what? 48. Then we update post sum, which is going to be 5 times the previous one. 5 times what was in the previous post sum. Post sum now becomes 30. I'm sorry, this part of the expression is maybe 2 bits, one blade. I don't know. But when we're solving it here, it's going to get more interesting. 30. So go to the next one. So it's going to be 2 times 30, right? 60. Yeah, 5 times 6 is what? 30. Yeah, okay, yeah. It's going to be 30. 30 times 4 is 120. Then we update post 6. Post 6 will now be post sum. Post sum will now be 30 times 2. Remember, post sum is just the multiplication of everything to the left of that current index. So 30 times 2 will be 60. So the next one will be 60 times 1, 60. So we'll still end up with the same. It's just the reason why we're using pre-sum and post-sum is so that we don't have to start calculating. So at index 5, we don't have to start calculating it all over again. We already have the memory of the previous, so we can just add it to the new one to calculate it. Yeah, so let's move on to the code. All right, so as said before, we're going to have a new array. Let's call it results, because we'll return it at the end of it. We have a new array, and it's going to, we'll initialize it as 1, and it's going to be the length of the previous array, because of our result is always the length of the previous array. This our results of 4 array give us 4, of size 4 give us 4. Then the next thing we'll do is we have a pre-sum. We'll initialize it to 1. So in our first for loop would be increasing, we'll be updating the results. Okay, all right, let's call it n. In norms. Okay, let's just use the range and L of norms. Okay, and let's call it I. So the first thing we want to do is take the results, and at that current index we want to update it with what our pre-sum is. Remember, this is the first loop that is just updating the first array, because everything is initialized to 1. Okay, yeah. Then the next thing we want to do is we want to update our pre-sum. So our pre-sum would be that correct index times the previous pre-sum. So our pre-sum will be our previous pre-sum multiplied by the value of that correct index. So norms I. Yeah, so our presum initially starts from 1, then after the first iteration our presum will now be 4. So 4 is our new presum. It cannot affect the next array. So when it goes again, our next array is going to be equals to the presum. So basically this just for more clarity, we have 1 1 1 1 at first. Then after the first iteration, this is still 1, but then our presum now becomes, okay, given this original array 1 2 3 4, our presum now becomes 1 times 1. So next, our result at index 2, our result will just occupy this 1 directly because of the previous operation has already updated our presum with the result that the next one would need. That's basically what we're doing. Yeah. So the next thing is now to do it, but in the reverse. Do the same thing, but in the reverse order this time. So this time we're going to do a range of length of norms minus 1, minus 1, minus 1. What this does is just prints it in the reverse. So it gives me 3 2 1 0. Yes. So what we want to do in this situation is we want to do result. We want to update the current index, but this time we want to update it with what it was before, multiply by our post sum. We're going to create our post sum here. Post sum will be equals to 1. What it was before, multiplied by our post sum, and then we're going to update our post sum. So our post sum would be equals to our previous post sum plus norms I. So yeah, so basically what is happening is our first post sum will be 1, our next post sum will be 6, which is ready for the next iteration of 5. So our next post sum would be 30, which is ready for the next iteration of 2. That's what is happening. And finally we can return our results. Yeah, so what I'll just do is I'm just going to print so that we can actually understand what is going on. I'm just going to print the results for the first time. So if I print the results, oh my god. Alright, let's kind of see what's going on. 1 2 3 4 1 1 6 10 8 6. Sum. Oh, okay. Sorry, not multiplication, not addition, multiplication. Yeah. So the first time it updates the array here. The next time it updates this array, adding, multiplying to the rest of the. So the first time it updates the array as the presum. So everything as the pre. So everything before 2 is 1. The multiplication before 3, 2 times 1 is 2. The multiplication before 4, 3 times 2 times 1 is 6. After that, it now loops again, this time adding everything to the right. So everything to the right of 4 is 1. 1 times 6 is 6. Everything to the right of 3 is 4. 4 times 2 is 8. Everything to the right of 2 is 3 times 4, 12. 12 times 2 is 12. Everything to the right of 1 is 12 times 2, 24. 24 times 1 is 24. And remember, the presum and the postsum is to hold the value to the right and not the value to the left, so that we don't need to, we can easily know the next pre or post multiplication, so we don't need to have to calculate that result again. So yeah, I'm just going to submit this now. And it runs. All right, thank you.